what is inheritance. Okay, the word inheritance is used when you receive things from somewhere. For example, if you get an inheritance from your parents, it means you get money and assets from them. If you inherit physical characteristics from your parents, it means you got your genes from them. If you inherit knowledge from your teacher, it means you have got it from them. Okay, so it's fairly straightforward. So inheritance in JavaScript is basically the same thing, where you get properties and methods from the parent blueprint. Okay, so this means all instances actually inherit from their blueprints. So they inherit properties and methods in two ways. Number one, by creating a property or method directly upon creating the instance, and number two, via the prototype chain. So for example, an array is a blueprint for array instances. Okay, so we can create an array instance using a square bracket or new array. Both will produce the same result. Okay, this array 1 2 3 within a square bracket, and using new array syntax we'll get the same array. Okay, so if you console log this array, you won't see any methods, but you can use these methods like concat, slice, filter and map. You see, and the methods are actually within this proto. Okay, so let's go ahead and check. So basically, why can't we check the methods in them? Because these methods are located in the arrays prototype, as I have said. So we can expand this underscore proto underscore object in our Chrome DevTools, or in the Firefox DevTools we have our prototype object. Okay, there we can see this list of methods. Okay, see, these methods are available inside our underscore proto underscore. Okay, so array.prototype contains the methods. Okay, even in the Firefox we'll get this kind of visualization of the methods. So note, both this underscore proto underscore in Chrome and prototype in Firefox points to the prototype object. Okay, they're just written differently in different browsers. When you use map, JavaScript looks for map in the object itself. If map is not found, JavaScript will try to look for a prototype. If JavaScript finds a prototype, it continues to search for map in that prototype. So the correct definition for prototype is an object that instances can access when they are trying to look for a property. Okay, that's a prototype. So prototype chains. Here's what JavaScript does when you access a property. These are the steps. So step 1 is JavaScript checks if the property is available inside the object. If yes, JavaScript uses the property straight away. Step 2, if the property is not inside the object, JavaScript checks if there is a prototype available. Now if there is a prototype, repeat step 1 and check if the property is inside the prototype. And our step 3 is, if there are no more prototypes left and JavaScript cannot find the property, it does the following. It either returns undefined if we are trying to access a property, or it throws an error if we try to call a method. Okay, so let us just have a visual representation of it. So says this is our prototype chain. It starts here. So JavaScript is going to first check whether the property is in the object or not. If yes, it will use the property, and if no, then it's gonna check whether there is a prototype or not. If yes, so if it's yes, it will return back to our starting point. Else, in case of no, it will return undefined if it's a property. Else it will throw an error if it's a method. So how prototypal inheritance works? Say there's a class person. Okay, so the moment JavaScript finds there's a class person, it creates an empty object of person automatically by default. Okay, and now person's prototype points to this empty object. Okay, now we can add any attribute to this empty object using person.prototype. Let's see. So we are assigning say 29 to person.prototype.age. So for the newly created objects Jim and Sophia, the age will be 29. If we console log Jim.age or even Sophia.age, we'll get 29 as our output. Okay. So basically what has happened when we have created objects named Jim and Sophia, so when we create an object actually using new keyword, that is created in the memory. Okay, and this object gets underscore proto underscore attribute to it automatically. Now this proto points to the empty object which got created by default initially, right? And instant properties are also created for the object. Okay, so now let's change Jim's age. Okay, so Jim.age equal 18. So now if we console Jim's age, it's gonna show us 18. And at the same time, we are going to reassign our prototype age. So person.prototype.age equals, say, we are putting 25. Okay, we are assigning 25. So it will get changed from 29 to 25. And if now we are going to try to console Jim's age, it is going to show us 18. However, Sophia's age will be shown as 25. Okay, as we have not exclusively assigned any age to Sophia, as we have done in case of Jim. Hence, Sophia will continue to exhibit prototype's age when Sophia.age is being consoled. So basically, JavaScript will look for the age property in Jim. If found, it uses it. Okay, so the moment we have assigned 18 to Jim's age, it has used it and have shown us the output as 18. So when the age property was not exclusively provided for Jim, JavaScript was looking for the age property in Jim's proto, correct? Similarly, in case of Sophia, we haven't provided any age, so JavaScript was looking for the age property in Sophia's proto. Basically, Jim's and Sophia's proto are same. Hence, for both the cases, when proto's value was 25, it was showing 25. When its value was 29, it was showing 29. If we had modified the age of Sophia, okay, then it would have shown us Sophia's age instead of prototype's age. Okay, so modifying Jim's age or even Sophia's age is not going to modify the prototype's age. Okay, let's take our previous example from the beginning where we had not assigned Jim's age. Okay, so basically person.prototype.age equal 29, and hence Jim and Sophia will have the age property of its prototype. Okay, and hence its value will be 29 for them. Okay, however, the moment we reassign the value of prototype using this syntax, person.prototype equal curly braces age equal 18, then what happens? The initial prototype age was actually pointing to a different location, and now the reference gets shifted towards a new location in memory. Okay, and due to this, what happens? Jim and Sophia's proto continues to point to the previous older location. So now what will happen if we create a new object, say Krish, then Krish.age will show the newly assigned prototype's age, okay, which is 18 in our case, and Jim and Sophia will continue to show the older prototype age. So basically, the reference gets shifted from the older to a newer location in the memory, and cause of this, the new instant gets the newly assigned value of prototype, which points to a new location in memory. So if we sum up, we can say if we modify person.prototype, it doesn't affect the existing instances prototype, that is Jim's and Sophia's prototype remains unaffected. So the new instance created, say Krish, will use the modified prototype. Okay, so now let's go through a demo. So we will move to our browser's console, and then we're going to type this next person.prototype.age equal 29. So we're creating the two objects of the person class, okay, and assigning them their first name and last name. Now next we are checking Jim.age. Now as age is not a property of the Jim object, JavaScript is going to check for its prototype's age, and it's gonna assign Jim.age equal 29. Same goes for Sophia. So that's why Jim.age and say Sophia.age is being shown as 29, correct? Person.prototype.age is going to show us 29. Okay, obviously, because that is what being inherited by Jim and Sophia. Okay, now if we are going to assign a different value to Jim's age, that is Jim.age equal 18, it's gonna show us 18 for Jim.age, but for Sophia.age it is still going to show us 29. Okay, person.prototype.age is 29. If we're going to check Jim._proto_.age, it's still showing us 29 because Jim's prototype age is 29, but Jim.age is 18 that we have assigned. Okay, now let us assign a different age value to our prototype, but this time we are using a different syntax. We're putting age :4 within curly braces. Okay, so as discussed, type of syntax will lead to a change in location of the prototype's age. Okay, any new instance created will point towards this new prototype's age's location. Okay, however, the older instances that had already been created, they will still continue to point to the older location of our prototype.age. That means it will point to the older value, okay, not this new value 4. Okay, if we had written person.prototype.age equal 4, in that case there wouldn't have been any change in location of the memory for this prototype.age. So what would have happened? Our older instances would have continued pointing towards the older location, and hence the newly assigned value would have been assigned to them also. The newly assigned value of prototype.age would have been inherited by them also. However, as we have used this syntax, person.prototype equal age colon 4 within curly braces, in this case what has happened, this prototype.age is now pointing towards a different location of memory, and due to this any new instances will inherit this new age's value. However, our older instances will continue to point towards our older memory location of this prototype.age, and hence it will continue to have the older value of age. Now, until and unless we explicitly change our older instances prototype.age's value explicitly, okay, till then it will continue to refer to the older prototype age's value. Okay, so we can see Sophia.age is still showing 99 and Jim._proto_.age is still showing 29. Okay, now we'll create the new instance Krish, and we'll see that it's showing Krish.age equal 4. This is what I've described just now, that the newly assigned value of person.prototype age will get reflected by the new instances age. Okay, will get inherited by the new instance. Okay, let us try to change Jim's prototype's age explicitly. Okay, so in that case we'll assign a value, say 100. So now we can see that Sophia's age is also showing 100 because it is pointing to the same prototype. Okay, it's older memory location along with Jim. Okay, let's take the newer instance Krish's age. It is showing 4. Okay, not the older memory locations, older prototypes age that has just been changed. Okay, because it is pointing to the newer location, hence it is reflecting the value 4. That's all for today. Let's meet in our next video with a new topic. Till then, happy coding.